systems of equations, section 8.8. A system of equations is any two functions that go together. Okay, they're dating. They're going out. My parents used to say, going, what do you mean they're going out? Where are they going? I'm like, Mom, Dad, you just don't get it.
I want to show my mom.
The solution to the system is the ordered pair that solves both equations. So it's whatever value of x and y fit into both equations. Yeah, that'd be good. Both equations. So solve the system of equations for y equals 2x and y equals the opposite of x plus 3 by graphing. This is just like last night's homework. We're just doing 2 to find one solution. So we have, for this guy here, we have y equals 2x. What is my y-intercept? 0, exactly, because y equals mx plus b. Can someone remind me what that form is called? What's that form called?
Oh, I know.
What is it? Yes, keep going. What is it? Slope-intercept form. Slope-intercept form. That pantomime that I just did with somebody getting an interception, by the way. Okay. So my y-intercept for this guy is 0, and my slope is going to be 2 over 1 because that's the m. So my y-intercept is 0, and I go up 2 over 1, up 2 over 1. So I'm going to draw a line. Yesterday we used blue. What color should I use today?
Green.
Purple. We'll use. I love green too. Oops. In this equation of y equals 2x, it will. Oops. So here's one of them. I need to use my school-issued straight edge. Make sure that goes the correct way. So that's the first one. Next one I have is y equals the opposite of x plus 3. My y-intercept, what we learned yesterday, is 3, because that's the b in the y equals mx plus b, which is slope-intercept form. And my slope is going to be negative 1 over 1. It's going to be negative 1 over 1. How did I get that? The opposite of x. So that means that, with this slope-intercept form here, remember that m is always the slope. And whenever you have negative x, that's the same thing as negative 1 times x. So then we have the y-intercept is going to be positive 3, so that's going to be right here. And then it is rise over run. Rise over run. I'm rising negative 1. So am I going to go up or down? Down 1. So I go down 1, and then I go over 1 positive. Down 1, over 1. Down 1, over 1. So I have a couple of points. So now I can draw another line.
Does it matter which direction you draw the arrow? Because can you draw it like parallel to the other?
There will be times when they are parallel, then there's no solution on those. If you ever see two equations in a system of equations that have the same slope, you know right away that they are not going to be a solution unless they are the same line. So as it said, the solution is the ordered pair that solves both of these. Remember, any points on each of those lines would be a solution for their own equation, but the only time that it's going to solve both of them is where they share a point. Where do they share a point? Savant?
1, 2.
Yes. 1, 2. It's this point right here. It's this point right there. Okay? Oh, that's right. I think the problem might have been the slope part. That's why I might have lost a couple of you, but we'll do it again so we can have it down. That was impressive, Tommy. All right. So now we have system of equations. I have two different variables here. Now remember, whenever you have something stuck to one of the variables, you can tell that that's going to be the slope. All right, that's going to be the slope. So this one here is going to be similar to the y equals mx plus b, but it's in a little bit different order. I want to put it into that form. So when I have c equals 10 plus 0.1n, and do we like decimals though when we're dealing with coordinate plane? No. Isn't the slope a fraction anyway? So we can change this to a fraction. We can change this to a fraction. So I'm going to change that 1/10 into a fraction. 1/10 n. And through the commutative property of addition, I can change this to 1/10 n plus 10. 1/10 n plus 10. So my y-intercept is equal to 10. My slope is a positive 1/10. So if I were to keep this going up, eight, 9, 10. So I'm going to cross here. Then I'm going to go up 1 over 10. And I can't go up 1 because I can't see that. But what I can do, you know what? Let's change the values of this. Let's make this 10, 20, 30, 40, 50, 60, 70.
If you run into a problem like this on the homework, will we do this as well for our homework?
On your homework, I don't think that they have coordinate. Yeah, it's just blanks. They don't give you numbers. So let's make them all 10 digits. So each square is worth 10 now. Each line segment is 10. So I have my y-intercept is at 10. Yeah, we should. Yeah, maybe we just had the y-axis as actual. Let's do these by 2s. Let's do these by 2s, I guess. I'm going to rewrite these. So it'll be 2, 4, 6, 8, 10, 12, 14. These guys don't count. You won't have to rewrite them because there's nothing there. So you would be putting the 10 by 20 by that sort of thing. Okay, so now we have the y-intercept is 10. Third time's a charm. I'm going to change the color. And I'm going to go up 1 over 10. So up 1 over 10, up 1 over 10, up 1 over 10. I'm just doing it to show you guys how many is happening with that. Because it's rise, which is 1, over run, which is 10. I don't like this one. That's the solution to one of them. Now we have to find the other one. So I have C equals 5 and 2, or 1/5 actually, so 2/10. Come on. 2/10 n, which is the same thing as y. C equals. I'm going to move this up so I can not crouch. I want to make sure I didn't lose anybody what I just did with pink. And please do your notes in pencil, because there are times where we make mistakes. Find one. Get one. If you have a problem, solve it. Because 0.2 is 2/10, and I'm not going to simplify it because I know that my values are 2 and 10. No, it's still the same thing. Then it's equation within their system, yes. So I have my y-intercept is what? Someone raise your hand. Yes. 5, correct. And my slope is what, Maddie? 2/10. So I start at 5, so that's going to be halfway through here. And I'm going to rise 2, and I'm going to go over 10. Rise 2 over 10. Rise 2 over 10. Looks like I need to make some of my lines different. Yeah, I do. Yes?
Wouldn't that be 210?
Rise 2 over 10. Mm-hmm. Is that right? There we go. I need to grab this. So this is important. This is why you need to use a school issued straight edge. I can't go as straight right here as you can because it's trying to snap onto things. But I just looked over and I saw people with arced lines. Remember I told you use your school issued straight edge to draw these? So I need to make sure that this is straight, that it follows my slope. There we go. And I go up, I see that my x value is 50. And my y value looks like it's 15. And I'm going to double check that. How can I double check that? How? Beautiful. I'm going to put the values back in. So my n is x. Oops. 1/10 n is 50 plus 10. 1/10 of 50. Yeah. So that one checks out. So it is 15. How about the second one? 15 is equal to 5 plus 1/5 of 50. Yep, 15 is 15. Good. I substituted my x and y values in there. Because if you wouldn't have used a straight edge, you wouldn't have been able to find that it's 50 and 15 there. Let's do another one.
Let's hope that these do not have sections.
Yeah, they don't. We're good.
Okay.
All right, right away, I said something earlier in class. You should know something right away about this. As we look at that system of equations, do you remember what I said? Bunny bread? All right, we didn't get it. All right, let's see we did this. First one, y equals x plus 3. My y-intercept equals 3. My slope is 1. Y equals x plus 4. Y-intercept equals 4. Slope equals 1. So first one, I go to 3. 1, 2, 3. Okay, so there's the first line, y equals x plus 3. Okay, I'm hearing a lot of weights. Where's the 9? There is no 9. Underneath the orange line, or underneath the purple line.
We only need 1 point.
There's every single point underneath that. Whenever you have a slope of 1, it's really easy. You go from one corner to the box to the other corner of the box. So I have, the next one is x equals, y equals x plus 4, so I'm going to go with the 4. So what is the solution to this? There is no solution because parallel lines never touch. And the solution to a system of equations is where they meet. That's their intersection point. That's the solution. If they never intersect, there's no solution. Okay? They do not intersect. So no solution. No solution because of parallel lines. That's interesting. If you have a piece of paper, like this one that should have been turned in, fold it like this. Yep. Yeah, you can use any piece of paper as a straight edge, by the way, guys. I mean, all you need to do is just fold it once on a good fold. All right, no solution because of that. And to answer your question, yes, since 8th grade. Solve the system of equations y equals negative 2x plus 3 and 3y equals negative 6x plus 9 by graphing. Once again, we need to make it into, or one of these we need to make it into slope-intercept form so it's nice and friendly. My y-intercept for this one is 3 because that's the b. My slope is negative 2 over 1. 3y equals negative 6x plus 9. I need to get y by itself. Y is being multiplied by 3, so I'm going to divide both sides by 3. So we have the same exact line. The same exact line. So I'm going to go ahead and graph this. We have intercept of 3. I have a negative 2, 1, so here's the intercept. It goes at 3, and it's a negative 2, 1, so it's down 2 over 1, down 2 over 1. Because that's this number here, too. I'm going to make that better. So, how many solutions are there if they're the same line? Every single number. Every single time that you put a number in for this guy, it's going to come up to be the same solution as that one. So this answer is infinitely many. It's more loopy, though. Fish. You need to be... That's not using a straight edge. What are you supposed to be doing with that? And what did I show you using a paper? You even have your ID. Come on now. Don't be lazy. Savant. No, because that doesn't tell all the solutions. When you say infinite, it represents an unknown. Yeah. All right, page 415, 14 through 17, this is what that is. So it says the graphs of several equations are shown to the right. Write a solution to each pair of equations. Okay, so we're looking at line A and line C. This is on page 415 if you wanted to look at that at home tonight. Line A and line C. So here's line A, here's line C. And whenever we do a solution, what are we writing down? What's a solution to an equation or a system of equations? Yeah, where they intersect. Right? So line A and line C, they meet at 1, 2, 3, 1, 2, 3, 3. Okay? So we have -3, 3. That's where those two meet. Line B and C, so I'm looking at line B and line C. Those two meet at the origin, which is what?
0.
Good, 0, 0. Then we have line C and D. Line C and line D. 1, 2, 3, 4, 5.
Yes.
Yep. 1, 2, 3, 4, 5.
Oh, wait, it's 5, -5.
5, -5, yeah. And finally, B and D. B, D, 1, 2, 1. Yep, the first half of your homework. Actually, yeah, over half your homework is just like that. Yeah. So for page 24, or page 215, and 415 as well. Which is just this, write this down, y equals x, and y equals 3. So when y, okay, as Brandon just said, y and x are the same. And when are y and x the same? For this one, hold on. Well, first off, what's my my y-intercept?
3.
For this?
X.
Y equals mx plus b. Where is the plus b? It's not there, so what's the y-intercept? 0. And my slope is 1. This one here, my y-intercept is what? 0? So if I have y equals mx plus b, how does that fit into that? 3. It's 3. Good. Whoops. Hello. There. And my slope is 0?
Yes.
Yep, because it's when x is 0. So I'm going to draw these. Have a seat. Sit down. Slope is 1. Why is that? La, 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 la. Okay, then we have y equals 3. It's no slope, and the y-intercept is 3, so that's just going to be this. Whoops. Oh, whatever. Pushed the wrong button, but that's pretty straight anyway. So what's my solution? 4, 3. 2, 3. 1, 2, 3. 3, 3. And this is like the second half of your homework. All right, number 25. Let's see, which one is harder? Yep, we have 4 minutes, 3 minutes. We'll just do number 25. Oh, number 30. Wait, let's see, 30. Yeah, let's do 30. 30's harder. 30's harder. We have y equals negative x and y equals 0.5x plus 3.
Is that negative?
Yes, it's ugly though. There.
Why don't we change 0.5 to 5/10?
Let's change it to something even easier than 5/10. How about 1/2? So my y int, 0. Beautiful. You guys are catching on. I love it. You guys are so smart. My y int here, 3, because that's just the b. And my slope is 1/2. You do have to set this up every single time so you don't make any silly mistakes. I'm telling you, do that so you don't make any silly mistakes. You have to set up, I want you to look at your own y-intercept. I want you to look at your own slope before you start doing any lines. So for the first one, I have y-intercept is 0. My slope is -1, so that's -1 over 1. So down 1 over 1, down 1 over 1. The next one, I have my y-intercept of 3 and my slope, which is going to be 1/2, so which is up 1 over 2. Up 1 over 2. I do not want to do that. Going from 3, up 1 over 2, up 1 over 2, up 1 over 2. Yay! I see a point. And that is -2, 2.